right, everyone, it is now 6. So this microphone may or may not be working, but I'm going to try and talk a little bit more loudly so that those in the back are able to hear. If you haven't already heard, there are cookies in the front, courtesy of HackNC. So if you haven't gotten one already, feel free to get one. It is on row 2 over here. In the meantime, if you are attending HackNC, so if you registered for HackNC, please scan and fill out this form here. This will track your attendance for HackNC and will allow you to get points, I think, for merch, etc. And if you are a 290 student but not attending, hold for 1 second. There'll be another QR code in a minute. So I'll give everyone some time to fill this out, and then we'll get going. All right, I think from what I can see, everyone who's needed to scan it has scanned it. Again, this will be at the end of the slide deck as well. But first of all, thank you all for coming today. I know it's a bit late on a week where there's often a lot of midterms and other things, so it's great to see you all here. If you don't know who I am, if you're not from Com 290, my name's Ajay. I am one of the instructors of Com 290 this semester, and very excited to have this collaboration with HackNC. HackNC has always done great things. Has brought a lot of festivity and different companies and opportunities to UNC. So we appreciate the chance to be able to work with them. So today's workshop was called, which there's a slide right here, Introduction to APIs. So what is an API? That's what we're going to start out with. And an API is, of course, like many things in the computer science world and lingo, an acronym. This stands for Application Program or Application Programming Interface. And basically, APIs are tools that allows one computer to be able to access data from another and allows this easy communication between two computers and essentially allows data transfer. So being able to send data and retrieve data from a server. And this is a very, very powerful component of the software engineering and computer science toolkit. And it says here with use of APIs, engineers, so software engineers or anyone who's working on coding can connect the programs that they are writing to other programs or other computers via the internet. So we're going to do a bit of a discussion here. There seems to be pretty good self-contained groups here from what I can see in our zones. We're going to spend a few minutes. I would like everyone to kind of talk about why we might want our computers to be able to access data from the internet, what benefits that might bring to our code and to our program. So we'll spend 5 minutes doing this, and then we'll kind of listen and see what people are thinking. So feel free to discuss. Eat your cookies, etc. We'll get started now. All right, there's been some good discussions here. I would like someone maybe to share what they were thinking. Why would we want our programs to potentially connect to the internet? What are some benefits of that? Does anyone have any ideas? Sorry, the projector's light is kind of glaring in my eye here, so I might not really be able to see people too well. Any ideas? I know I heard some good stuff from row 2. I don't want to call anyone out, but if you want to share with what you had said, feel free. It's good.
Which is that without APIs, you'd have to code every function, every part of your software's functionality in yourself.
Yep.
But I mean, because of access to the internet, there's so many packages all over the world. So many functionality, like ChatGPT, for example. A lot of apps you generate API nowadays, and instead of having to code your own model, which would take billions of dollars of investment, you can just pay OpenAI for a subscription, and you can access their API and integrate their functionality into your app. So
yeah, so that's a great that sums it up very well. So nice work. So sorry, that's why I wanted to call you all out because that was a great. I heard that. So yes, this is a very important idea, right? I mean, there's so many different software and different packages that people make, and they post online. They have data, and they have a lot of resources available. And why would, in certain cases, it would be easier for us in our program to be able to access that and make use of it without having to do all of that re-engineering ourselves. So that is a great idea. And in general as well, you'll find that there's a lot of data out there, and we'll be looking through an example today of this, where people are collecting thousands or millions of data points, and instead of doing that ourselves and collecting all of it, we can just access data that's publicly available. And that's another example of where we might want to connect to the internet. So great work and great discussions there. So yes, the key idea here, and if you were in 290, you may recognize this diagram here, but the key idea is that we want to be able to transfer data and transfer information from somewhere else on the internet. That could be, on a server or something anywhere, and we want to be able to access that in our own program. And so we have kind of this, we have this model here where you may have our program, which is written here and represented by this laptop, where we might want to request some data from some other server or whatever, and then the server should respond back with that data. And this happens across the internet. Specifically, if we want to get more specific about this, uses something called HTTP, which if you're not in 290, you might recognize from, when you type in something to your the search bar on Google or go to a website, it says HTTP. It's the same idea here. We want to be able to request data from some external source and then access it in our application without having to download all that data manually beforehand and hard code everything. So I also want to do one more, if you will bear with me here with discussion. We already had one example, but if, let's say that we have these APIs that allow us to get this data, any data that we like from some external source, what are types of apps or projects that you might want to, or you might create that would utilize going and getting some sort of external data? So we're going to spend maybe 2 to 3 minutes on this, and then we'll get a little bit more hands-on. So feel free to discuss in the same groups as last time, and we'll see. All right, so silent. That's fine. I will actually, because I know I heard some different ones, so I'll talk about this. So one, I know that actually in the front is already mentioned in the previous example, which was AI and AI bots, right? So ChatGPT is an example where you may want to have AI in your application in some way, and of course ChatGPT is a chatbot, right? You send it some sort of message, and then it sends back a response. And that really well follows this diagram of your computer. You would type in some message, and it would be sent over to ChatGPT's server, and then ChatGPT would send back some sort of a text response. And so that is something that you can build into your own apps as well. So ChatGPT gives you the ability to have access to the server, and they charge, I think, this one example of where ChatGPT charges because it's, that's a very popular service, but that is a great example of being able to use an API. There's many other ones I heard of, I think I heard flight, some flight information, something that was great. Stock prices, right? This is data that you wouldn't be able to just calculate or figure out if you didn't have the internet, right? You need to access it on the internet. Fitness trackers, weather apps. This is one that we'll look at a little bit more today, and that's kind of a common one that I like, because weather is something where there's so much data out there, and you need to forecast. You have to forecast weather sometimes, and that's not something that you can really easily do on your device. You'd rather just ask for the data and retrieve it. So any apps that really require real-time data or dynamic data, and when I say dynamic, I mean changing, so that it changes live, those are apps that utilize this thing called APIs. And you'll find that nearly every app on your phone right now, every popular app, every built-in app, nearly everything uses the internet in some way, and all of them use APIs. Websites as well use APIs. So pretty much, if you're able to begin learning and begin working with APIs, you've unlocked a very, very large part of functionality for most software projects. Now, the example that we're going to be kind of looking at for this segment is with the weather app idea. And the common thing here is you can have many different apps. So you can have a weather website, a weather app, maybe even a smartwatch app. And all of them may do the same thing, where they'll request some data from a central weather server of some kind, and then that server will respond with some data. And so the server's job is to basically, whenever somebody asks for data, it's going to send data out. And that data is supposed to be the most up-to-date weather information. Now, a little bit of a bigger picture here, because we talk about APIs, and this is, of course, a workshop for HackNC. And in HackNC, you'll be working on many different types of projects. Some people will be making websites, some will be making apps, some will be making something completely different. And all of those different types of projects use different programming languages, right? So if you're working on a website, or maybe even like some sort of data science app or an AI app, very likely that you'll be using Python to do so. If you're making a web app, you'll be probably using JavaScript, TypeScript, iOS, maybe Swift, etc. And the thing is that even though, so this example that we're going to be doing today is going to utilize Python. The reason is because that's the most accessible. Comp 110 students will be able to use it. But even though we're using Python here, all of the same things that we're talking about can be used across all of these languages. And in fact, in a lot of the slides, when I mention something in Python, I'll at least mention the alternative one in the other language. So the key thing is learning the concept, and then once you learn the concept, you'll be able to apply it in any language of your choice. Right? So we're going to be using Python here. It's the most accessible. So there's a very cool website called Google Colab, and if any of you have worked in, maybe if you've had a stats class, you may have used this. This allows us to essentially work on code in this notebook style format. So if you go to this link, I'm going to quickly show you what you would see, and then I'll go back to the link so that you can access it if you need. It should look something like this. So you'll find this file open, and you'll see that this just allows you to run code very nicely in this notebook format. The reason why I want to use this one rather than like some sort of project in Python or something else like in Visual Studio is because there's a lot of setup things that are often required. And in Google Colab, it's very easy to set up everything. And that way you all will be able to follow along without being bogged too much down by setup. So when you access this, try and go to this file tab. And I think there should be like a duplicate or like save a copy. Save a copy and drive, because I don't think this should be editable for you all. So try and save a copy and drive so you have your own version, and then we'll work off of that. Just to go back, so everyone has access to this link, this is what the link is. So it's go.unc.edu/hacknc-apis. So I'll leave this up here for a few minutes. That way everyone gets set up, and we'll have some, try and duplicate this notebook as well, and we'll come around and make sure if you have any questions, we'll get those answered. So spend a few minutes on that. Yes, so Noah, who is the other instructor 290, is now here. So if you have any issues, feel free to raise your hand, and he'll also be able to come around and help debug some things if needed. So. But yeah, of course. You could just waiting on this. All right, so did everyone have the link? Were able to get here? Great. Okay. I'll also, you know what? For the sake of this, just write this here as well. All right. So this is now also on the board if you need it. So if everybody has duplicated this, we can probably get started. So let me pull up this here. So I'm going to make this a bit larger. So you see here that there is some text, which kind of helps, some comments as well in our code to be able to explain certain things. That way, if you're ever looking at this, like let's say in the event you want to do something with APIs, you should have access to this, and the comments will maybe help to explain some things. So the first thing here is I have this thing already installed, and so by duplicating this file, you all should already have, you should be able to run this code with no problem. And so if you've not seen notebooks before, I don't really know if they use this anymore in 110. If you took Comp 116 though, there's a chance you've seen this. But basically you can run each of these code blocks as their own, each of these cells, as they call it, as their own blocks. So if you press run, it's going to run the code in this section here. And the first time might take a second, so you see it runs it. And then we can go down here and run another cell, and it will just run our code. So this will be an easy way for us to work with our code. So I encourage you, run the first 2 cells. So let's explain what's happening here. So the first thing is that Python, there's this tool called requests, and you can import, this is a package. And with requests, in fact, here it is. It gave some detail here. What does this allow you to do? Well, it allows you to make what are known as HTTP requests, right? And so if we go back to the diagram that I had on here, which is over here, this diagram, right? We're saying here that whenever we want data, we need to request it, right? We need to send a request to a server. And we do that by sending an HTTP request. So we can use, in Python, it's very nice, there's this built-in request package that we can use to do so. Now, I also have something else here, which is a URL. And this URL takes us to an API. So remember, API is just any software that allows us to be able to communicate with and get data from, maybe a server. And there's this link right here, which is this goweather.herokuapp.com/weather/Raleigh. And so if I go to this URL, you'll see that a website doesn't show up here, but all this text shows up. And let me make this a little bit bigger. There we go. That's as big as it lets me make it. So you can see that there is text here. We see some weather-related information, right? Like we see partly cloudy as a description, right? That sounds like weather. We have temperature, right? 23 Celsius here, forecast, etc. And so this is raw data. And what we did using Safari or any browser of your choice, we went to this URL. And whenever you're in a web browser, like Safari or Chrome, and you type in a URL, it's going to be making a request, right, for any website. So if you went to, for example, UNC.edu, or you went to apple.com, or something like that, every time you do that in your browser, like I'll go to UNC.edu right here, what's actually happening is our computer is sending a request, an HTTP request, out to the server that has this website on it. And then the server is going to respond to your computer with that website. And so that's how we're able to access web pages. In the same way that we can use this to access web pages, we can access data as well. So this URL here, what I'll look at right here, this URL brings us a weather forecast, and it brings us the weather forecast for Raleigh. And I can put any other city in here, and it would also provide the forecast for that city. So using this URL in our Python code, let's try and get this data for ourselves. So I'm going to skip, there's some text here, kind of explaining a little bit more about what HTTP is talking about and sending requests. For example here, whenever we send a request, there's actually 4 different types of requests. Today we're only going to be focusing on the first one, which is retrieving information. But as you progress and as you learn more about APIs, in fact, I believe, I don't know, so don't quote me on this, I think on Saturday there's a workshop hosted by Pendo, which is going to talk a little bit more about these ones. So this is like, ours is going to focus on retrieving data and working with it, but actually updating resources, posting new information to a server, all that, I'm sure that Pendo will talk about a little bit more. So I recommend attending. But using requests, let's try and access our data. So to do this, all we have to do is we can type in, so requests is the name here of the package that we're using. So requests is, remember, what we imported here. That's the tool that we'll use to access our data. And now, this package gives us different options. So it should give us these 4, get, post, put, and delete. for how we want to send, what type of request we want to send. We'll send a GET request. And then in here, you'll see that this Google Colab tells me what I should pass in, which is a URL. Right? So we want the URL for what we're trying to request. And since we saved our URL up here, or our URL up here in this variable, we can pass that in to this function. So I can say request.getURL. And if you run this, you'll see that you have this weird looking object right here. So I'll give people a minute. And of course, if you have any issues, Noah is watching from the corner of the room, so he'll be able to help debug on your computer if there's like a setup issue. But what does this mean? So we obviously sent out a request according to my diagram right over here. We sent a request, and our API is supposed to send back a response. And it looks like, right? We have a response. It says that there's a response. And then there's this code 200 here. If you take a higher level class in the CS department, you might recognize 200. Basically, all this is saying is that your request succeeded. So there was no errors when you were trying to access your data. The problem is, though, we don't have any data here, right? We just have this response object. And so what I can do is let me save this response object to a variable. I can call this response. And if you haven't used Collab before, basically, whenever you put, like let's say I have response equals request.get, if I add response as the last line and run it, it's just going to print out the last, it'll just print out response. That's just a feature of Collab. So if you notice at any point that I write just a variable randomly down here, that's just so that we can see what it is. All right, so we've saved this as a response, and I'll run this right here. You'll see a check mark, meaning that we've ran our code. And so now, let's actually retrieve the data. How do I do that? Well, I'm going to say response, and then you see here in my instructions, I write .json, .json, and we'll explain what that is in a minute, because it seems that if you've never seen this before, this is probably a bit peculiar. If we run this, though, now this looks familiar, right? This is our data. So this is the data that we tried accessing over here. And just like we did with our response, let's save our response to a variable. I'll save it as data. And again, since if I put something on the last line, it should print it out. So stop here for a second. Let everyone get this written up. We'll explore what JSON means in a second. So JSON, and I'll kind of cut to the chase here a little bit as to what this data variable is looking at. But data is actually treated as a dictionary in Python. If you're in 110, I hope I checked the schedule. I think you all may have talked about this, but if you haven't, just the data, if I have data and I want to access, right, one of these attributes, so you see here I have temperature, and temperature maps to this string of 23 Celsius, wind maps to 10 kilometers an hour. If I just add brackets and like type in one of those keys, like wind, and I print it out, you should see that it gives me that value back of 10 kilometers per hour. Okay? So let's see. All right. So let's do one other thing here. Let's go to this cell right here. So what I want to do is I ran this code here, which gives me, right, I have a URL. I get the response, and then I do this .json, right, whatever that is, to get our data. I'm going to write a very quick function here that allows us to kind of repeat this process, and that way you can see what is actually required in making getting data from an API. So I'm going to write a getWeather function, so getWeather, and what I really want is I want to be able to get the weather for any location that I type in, right? So ideally, I'd want a location as my input, and then my output should be the data that I see up here but for that location, right? So how would we do this? Well, remember there's three main steps that we've done, right? The first one, step one, was create the URL, right? Step two was this right here of making a GET request, so make a GET request. And three, which was to load the data, or get the data out, right, of the response. All right? So I've added some comments, and now let's just copy this stuff over. So creating a URL. So my URL is just going to be, well, let's look up here. We have this string, right, for our, which represents our URL. The only thing that changes, though, is this last part, because that's the location that we want to input. So let me copy this and paste it here. And what I can do is I can just pass in my, so instead of this Raleigh, I can just delete that, and we'll add a location. Whatever our location is, we just want to add it to the end of our URL, right? So if we're Raleigh, it's /weather/Raleigh. If it's Charlotte, it's /weather/Charlotte, etc. And actually, the rest of it is just copying what we had, right? So we have getting our response, right? So we make a request to this weather server with that URL, and then it's going to give us that weird response 200 object. And then we need our data out. So let's say data equals response.json. And of course, since this is a function, we want to return our results. So return data. Now, remember that when you write this out, you'll want to run this cell before we run the next one. Because if we don't run this, our function doesn't get created. And now, if I run this, you'll see all the weather. I'll make sure not to hide too much of the top if you're still copying. All of our weather for our three locations of Raleigh, Charlotte, and New York have been printed out. Are there any questions about the process that we have followed so far in terms of creating our URL, getting our data, and creating this weird JSON thing with it, which we'll get to in a second? All right, it's looking pretty good. So let's talk about this, right? So we have this response.json, but what does this really mean, right? And that's a key thing here. So I think I went through that already. Yeah. So notice that our APIs return data in what's known as JSON. And now JSON, like APIs and many things in CS, this is another acronym. You don't really have to know what this means, but basically it is a textual representation of any sort of data or object, right? So typically the way this came about is, if you learned in Python or maybe in Comp 210 or something with objects and object-oriented programming, there's a way to represent data as one, like cohesive unit in our code. Well, that JavaScript is a programming language, and they created a way to represent this as text data, so it's easily transferable between computers. Now, of course, if you look at this, let me get back. This might not be that easy, and we will see, yeah, this is our data. It might not really be that easy to use this, right? Because this is JSON format data, this is text data, but we're used to working with objects, right, in Python and in other programming languages. So we don't want to just be able to work with to this raw text data. Now the cool thing is with our request package, we are able to get our objects like these dictionaries. So as you saw, we could work with our data. Sorry, where are we here? We could get data using like this and data, wind, etc., and that gets our data. But it still might not be the easiest to use. And this really comes back now to what we kind of call a pipeline, right? Or what are the different steps that we need to actually go through when we're working with APIs? So retrieving the data is just step one. So that's what we did. We went to a URL, we grabbed data, and it gave us this data in JSON format. But most of the time, right, you don't want to use just JSON data. we actually want to convert our JSON into objects that are native to our programming language. So then we can just use our data kind of in a way that's very natural and intuitive in the language of our choice. And so what we did is we focused on step 1 right now, which is just retrieving the data. And what we're going to do next is we want to move to actually modeling our data, or what we call deserialize, a fancy term, the data. And all this is we're taking now our JSON, that text with the curly braces and all this stuff, right, here, all this, and we want to convert this into objects of our language. Okay? So we want to model, right? Basically, what we want to do is we want to create a template for objects that we want to create in our programming language that will model the data that we are trying to work with. And then our goal is we want to take the JSON and then just convert it over into these objects, and then we don't have to worry about any of this anymore, like any web stuff, JSON, anything. We just use normal like Python objects or Swift objects or whatever language we're working with. And this conversion process of being able to take JSON and converting it into an object is in every programming language, or most of them. And Python uses, we use this package called Pydantic, which makes it really easy to do this process. So it's only a few lines of code. In JavaScript, this is kind of because we're using JSON, and JSON is, there's built-in tools in JavaScript to be able to handle that. In something like Swift, there's something called JSON decoder. And no matter what types of project you're working on, if you just search, if you search this right here, deserializing data in X programming language, you'll typically find the tool that allows you to do it. But the steps that we're going to take today are the same, or should be relatively the same across any language. Okay, so let's go back to Collab here, and I will showcase this. So Pydantic might not be installed for everybody, just because that it worked for me the first time, but I tried it on another computer and it wasn't installed. So if it wasn't installed in Google Colab, you could just run this, and I would just run this anyway. That way it can tell you, see, it tells me that requirement already satisfied, meaning we've already installed it. But this will just help you install Pydantic, which is the tool we're going to use to convert JSON to objects. And then we'll import it, so now we can use Pydantic in our code. Okay, so I'll give everyone a second here for that. Okay, just to get everything installed and good. If anyone has any questions, of course, please raise your hand, or if you have any issues with your code, and we'll be able to help you. Okay. All right, I think most people have probably gotten there now. So let's get started. So what is the idea here? We're trying to convert this JSON right here into objects. So we have our JSON, but what about our object, right? We want to convert this to an object, but we need to define what that object is going to look like. We need to make a template that says, in Python, we want our object to look like this. Let's say it's our weather data, and it needs to have certain fields, etc. in it. So we can do so down here. So if you're in, I think 110 also should, they may have gotten to this already. If they haven't, it's coming up, but this keyword class right here. And class allows us to create templates for what these objects, or what they're going to look like. And so let's say that I want to create a weather object right here. So I would follow along. So we're creating a weather object. And our weather object is going to store the data. It's going to essentially look very similar to this up here, which is going to store these things, right? Temperature. Actually, what I'll do, I'll just go to this. That way it's easy to switch. So it'll look something like this, right? So we'll have temperature data, wind, description, etc. Okay. So this is step one. Now, what we want to also do is this is maybe slightly conceptually slightly above where 110 or 210 is at. So I would just copy this here and I'll explain very briefly. Well, right here, Pydantic.base model. And what this basically is telling our program is this weather thing that we're writing here, this is a template for for data that we're going to be using with Pydantic. That's kind of the explanation that I'll give here, because I don't want to go too into the weeds. But by writing this weather class that we're writing will have all of the Pydantic functionality. So Pydantic allows us to convert from JSON and take JSON and convert it to objects and vice versa. And so just by adding this, we're just giving this weather class that functionality. And I'll even write a comment here. So I'll just say this defines a weather object in our code. Or maybe that might be more descriptive. That way this makes sense. Defines a template for what a weather object should look like. Now, how do we proceed from here? Well, let's look at our data again. And our data has these different, and this might be slightly harder to see here, but we have temperature data, so that's one thing. And notice that temperature data here is actually passed in as that's a string, right? There's quotes, just like you've seen. Then we have wind data, which is right here, right? And this is a string. We have a description data, and that's also a string. And then we have forecast. And let's get to forecast after, because this you'll notice this is a list, right? This is a list of data. So let's get started with the easy ones first. So we'll have temperature. I'll write this here, temperature. This is a string. Wind is a string, and I think there was day as well, right? Did I miss day? Actually, no, sorry. Just temperature, wind, description. That's what I meant. Description, string. And this just defines all the different properties that our object will have. So when we're working with our objects, we see these things. Okay. Great. Now, the last thing is we have this list here. You'll see here, this is a forecast, and then we have all this list. And what a forecast is saying here is we have different days. So 1 day out, here's the weather. 2 days out, here's the weather. 3 days out, here's the weather, etc. And you'll see that each of these items in our list are also these JSON objects with their own data, right? Day, temperature, and wind. Then there's another one right here for day 2. If I highlight that, this is day, temperature, wind. The third one, day, temperature, wind. So let's create another, because we want a list here. So this would be like forecast and list. But we need to specify what type of data we're storing in our list. And we can do that by creating one more of our classes. So this class is for weather, but let's create a forecast, one for our forecast. So class forecast item. And just like before, because we're using Pydantic with this, we'll use Pydantic base model. And if we look again, apologize, and your copy, I'll give it a second. I just want to switch back so I can show you, remember those 3 things. So we are using day, temperature, and wind, right? So let's add that. We have day, temperature, wind. And we're providing our data types just like you would in Python. And so this is like data for an individual forecast day. Whoops, sorry about that. I need 3 quotes for this type of comment. Okay. And so now it would make sense that this forecast item, this is the data that we're modeling for every forecast, like every day in our forecast. Let's add this here because our forecast would be a list of these types of items, right? And so this defines these define our 2 objects for weather and forecast item. We'll run that. I'll give people a second in case you're still writing here. Okay. Okay, I can actually, I have access to the cell while this is still up here. So the next thing, now that we have our data, like we were saying here that we have weather, and we were saying this is what it means to be weather data. We need to have these properties. Let's convert our JSON to this weather object so we can work with it like we would with any other Python object. And so first, let's get our JSON data for Raleigh, let's say. This as an example. So I can just say Raleigh JSON. And remember, up here, we just use get weather and then Raleigh to get our JSON data because we made a function for it. So I can copy that, paste it down here. And remember, I can just add this here to print this out. So we'll print it. That's our data. Right? That is in this JSON format. It's the string version of what our data looks like. And so now, how would we convert from this to our weather data? Well, there's a feature in them. That's the reason why we added this Pydantic here. This gives a special method to weather that we can then access to convert our data over. And it's called model validate. So I'm going to scroll down. And what I'll do here is weather. We'll access weather as a, like with capital weather and then dot. And then there's model validate. And what model validate does is we pass in JSON data, and it will convert that JSON data into a weather object. So if we take Raleigh JSON, we paste it in here, and we run this, you'll now see that what we've created is a very nice weather object which stores all of the same data that we accessed. And this is great because let's say I save this as like Raleigh, and I want some sort of data like the temperature in Raleigh. All I have to write is now Raleigh.temperature. And it runs, right? Just like a normal object. And so this step is that second piece of our diagram of taking our JSON data, which is this raw data from the server, and now converting it into data that our programs can actually use. And this step is a really big, this is a very key part in a lot of when you're making software and you're working with data, because often working with this JSON data is really hard to work with, and it's better to use objects here that we define ourselves, so like weather. All right? And we can confirm if I were to do, like there's a special function in Python called type, and I type in Raleigh, and I run this, we get, you can see here, this is a weather object, it's not JSON. Right? If I compare this to Raleigh JSON, we get a dictionary. Right? So you can see the difference here in types between the Raleigh JSON and Raleigh. Now, a quick thing, if you're ever wondering that, oh, what if I want to convert back? Is there a way to go backwards? We went from JSON to weather. Can we go back? Yes, we can. This is just using, it's actually kind of funny. It's just Raleigh.json, just like before. .json, if we print this out, we get back our JSON data. And you can actually see this time, this is definitely a string. This isn't a dictionary at all. It's surrounded by quotes. So that is how to convert backwards. All right. Are there any questions about the process that we've done here? So just to recap again, we took JSON data. This came from our server, right? This came from the internet, and this is in a format that isn't the best to use in our code. So we created we wrote a template for what this data should look like in our program. Then we converted the JSON data over to our new object that we made, or this new type, weather. Okay? Everyone good? Oh, yeah, sorry.
Quick question. Like,
Yeah.
So like for the weather and the forecast item, does the stuff inside have to be the exact same name as the JSON data, or are you just doing it so it's clear?
Are you saying like day, temperature, wind, that type of stuff, or?
Yeah, like
Yeah.
where we define like temperature as a string, wind as a string.
Yeah.
Like does the word temperature have to match
Yes, good. Thank you for bringing that up, actually. That's a very good point. Yes, it does have to match. I probably should have clarified. So the idea here is whenever Pydantic has this model validate, it uses the names of like the data that you're passing in and then those parameter names and trying to match them together. So if, for example, I change this to say temp here, I'm just as an example, I run this and then I try, I get my data and I try converting it, there should be an error because the data doesn't match up, right, with the type. So you can see here, this temp, there's an error with temp because it's trying to look for this data in that JSON we sent it and it doesn't exist, right? We only have temperature. So yeah, thank you for bringing that up. All right, so that was step 2, right? So we're converting from JSON to regular objects. Now, in our code, we're actually able to use these objects ourselves. So now, if you, for example, wanted to make a weather app, you can take that data and very easily make something interesting with it. I'm going to skip. I'm going to go back to the Collab into the code because I want to talk about something else that I think might be helpful, especially if you're working in HackNC. So the process we did, going from raw data, converting it over, and then and now being able to use the data in the object format of our language, sometimes, and very nicely, some developers will actually automate or make something called a wrapper, which allows you to do it basically does all of this for you. So, and there are some cases where it's very nice because the developer has already written, like in every language, like in Python, you just import something and then you can just say .get data and it just does it. You don't have to do any of these steps. And it usually hides the API requests and that conversion logic for you. It's all written kind of in native, like in code that seems recognizable. And there's a cool example I want to bring up here. If anyone has played Pokemon before, there's a very cool API here called the Poke API. And you can actually see that this API, there are 2.5 billion requests to this API every month. Right? So you can just imagine how many people there are on this planet. I think there's 8 billion. And somehow 2.5 billion requests are made to this server every month. Right? So any apps that are like Pokemon-related apps or websites, etc., they get data from here. And behind the scenes, they're using this API. Right? They're not storing. There's like, if you've ever played or watched anything with Pokemon, there's like 1,000 different Pokemon types, right? Species. All those apps are not downloading all that data and just storing it like as text files in their app, right? Because that's a lot of data, like a lot of images and things to keep track of. Instead, it just calls this API, gets the data, and then works with it. And so that's something that's very interesting that these type of apps, are utilizing these free APIs. For example, if I copy this URL right here, I can actually press submit, I think, and it will do it for me. Maybe not. Let's try. So I copy and I paste, and look at that. So you can see instantly I requested data for a specific Pokemon, and now we have an entire page here of data. Now, can you imagine trying to make a model like how we did with Pydantic to try and capture that? That would be a nightmare, right? Because look how long, it's very hard to even read what this says. And so luckily, the people who made this API created what's called a wrapper that allows you to use this very easily in your programming language. So if you go to, I believe is it an about? Oh, look, what's an API? There it is, right there. I think there is I might need to look it up if it's not here. Documentation, maybe this. There are ads, unfortunately. All right, so see here in the documentation, there's something called wrapper libraries. And when you click on this, let me refresh because the formatting. There we go. Maybe not. What is happening here? There's a lot of stuff which used to not be on this website. I don't know what's happening, but I'll zoom in and hopefully ignore all of the all the ads for some reason. I used this last year and there were no ads, so maybe those 2.5 billion requests are probably costing them a lot of money. Let's just keep it at that. But basically, wrapper libraries, you can see for every type of language, right? Python, for example, there's something called PokePy, right? Which is like a kind of a play on Pokemon in Python. This code, you can just say pip install this PokePy, and then you just use like functions like get Pokemon. It will just return the data for you. So this hides all of that work of saying, oh, I need to get a URL, make a model for it, do all the conversions. It just does it, and it then returns an object for you to use. And using wrappers, especially in something like HackNC, if you want to work with a lot of, if you're working with a lot of data, it might be beneficial to try looking for a wrapper library first that's easy to interface with and get data with, rather than having to reinvent the wheel. Now, there are some cases where you'll have to do the steps that we showed. And if you're trying to work on a specific project, you want to make your own API. You want to go through this process yourself. And it's really good, it's really useful to kind of understand behind the scenes how all of this is working. Because if you're ever working on this on your own, these steps are very important. And that's the reason why I wanted to showcase those. Now, as someone in row 2 mentioned earlier, many APIs are free. Like the Poke API is completely free, but there are also some that are not free, and some are also free but with some sort of limits, meaning that you can't access this like 100 times in an hour. You can only access data a certain amount of times. And so when you're working, if you want to use APIs and use external data in your programs, you want to make sure that you're choosing free APIs, especially for something like HackNC, right? You don't want to probably spend a lot of money on APIs. So make sure you do your research and look for APIs that are free if possible. You may even sometimes have to call, if you find that URL, you can do the steps that we did. For example, ChatGPT, they charge for using their API. But there might be other tools, other AI tools. Maybe Noah, you might know if there's any that are free. Right now, though, most AI tools do cost something because it's kind of it's a very big area right now. But I would imagine maybe in a few years, AI might become accessible enough where there are free APIs that are available. Are there any questions? Oh yeah, yeah.
Just a recommendation.
Yep.
If you Google GitHub. Public APIs, it gives you like an enormous list of
yes, let's do that. GitHub public APIs. Thank you. This is something, yep, I have been here before. This is actually, thank you for mentioning this because this will actually help everybody. So this particular link, and maybe I'll provide, I'll send this out as well to the people who came. This gives you a very, very nice list of different APIs for all the different categories. So for example, animals, if you're interested, anime, I think is popular with a lot of people. There's all these APIs here, and it tells you like, see, quotes are over 100 plus. There's like facts, and there's different columns. So if auth, so the auth is a good way to check if something will be free or not, because a lot of times if it's not free, like if you have to pay, they'll give you like what they call a key, an API key, which is just like a password that allows you to access it. So for all these ones like over here, these seem free for the most part. You can see there are a lot of different ones there, but there's so many things, right? Pokemon was one that we did. There's anime. I mean, there's I know a lot of people are interested. There's always usually sports projects and fitness. You can see there's all these different APIs like bikes around the world, right? So when you're working on your HackNC projects, I highly recommend. And again, thank you to your fellow student. This is a website that you all should check out because there are so many APIs, and as you're working on your own projects, you might find an API in here that will really that'll help to transform your project. You can either go through the steps that we did of getting data and converting data, or you can use some sort of built-in wrapper. Now, there is one thing I know I'm going to skip this piece because we are out of time, and there's some code that I provided just to show you working with our weather data that we did. I'll send that out. One other thing which I recommend checking out, I know HackNC has a theme. It's the Space and Galaxy this year. There are many space-themed APIs. So if for whatever reason you're interested in potentially doing a project that's kind of around HackNC's theme, you can try to look for APIs. And if you want to spend a few minutes afterwards working on this, I'll be here for a little bit more if you want to try this out. But otherwise, since we are running short, I will put up the attendance form again. So if you came late for whatever reason and didn't have a chance to scan this, and you're attending HackNC, please scan this. And then if you're a 290 student who maybe came a little bit late, there'll be another code in a minute. Again, though, I want to stress that there is a workshop that's going to be hosted by Pendo. They're a local company here. They do a lot of good work, and they're collaborating a lot with UNC. They are going to be hosting another API workshop that's actually going to go a little bit more in depth on how you make APIs on the other side. So that'll be really cool. I highly recommend checking it out. That'll be during the event on Saturday. But even if you're not attending the event, I'm sure that it's going to be in here, so I'm sure there'll be a lot of space. So I highly recommend checking it out. And thank you all for coming today. We'll answer any questions if you have any. Thank you. And if you're in 290, here's the 290 code. Yep.